So we now want to look at polynomial inequalities. We're going to begin with a quadratic inequality. X squared is less than or equal to 4x plus 12. We want to determine where on our number line this is a true statement. So the first thing that we need to do, just like if we were solving a quadratic equation, is we need to get all of our terms on one side of the inequality. So I'm going to begin by subtracting the 4x from both sides of the expression. So that's going to give me x squared minus 4x is less than or equal to 12. Then I'm going to do the same thing with the 12. So we'll subtract the 12 from both sides of the inequality. And so our expression now will read x squared minus 4x minus 12 is less than or equal to 0. So again, this is exactly what you would do if you were solving it as an equation. You would need all of your terms on one side. So the same rule applies for an inequality. The next step, if you were solving it as an equation, if we had an equal to in between, would be to attempt to factor the expression. So we're going to do the same thing here. And when we do that, we're essentially working at finding the zeros for the left side of the expression. So I'm going to take this x squared minus 4x minus 12. I'm going to set it equal to 0 and I'm going to factor. So we'll have x and x for the x squared. For the 12, we'll do a 6 and a 2 because that will combine easily to make 4 in the middle. Because our 4 in the middle is negative, we want the bigger term to be negative, and the smaller one would need to be positive. Now that we have our quadratic equation factored, we're going to set each of those factors to 0. So we'll say x minus 6 is equal to 0, and x plus 2 is equal to 0. And we'll work at solving those. So in the first one, we're going to add 6 to both sides, which is going to give me a 0 at x is equal to 6. And on the second one, we'll subtract 2 from both sides, which is going to give me a 0 at negative 2. Now remember that these are the points that we would expect that the graph would see a change from going to a positive to a negative. Because remember, these are the places where the graph is crossing the x-axis. So we looked at this in the last section, but we'll do it again here. So if we have a 0 at negative 2, we expect that that's a place where the graph is crossing the x-axis. And so the graph might be positive on one side, and then when it crosses the x-axis, it's going to turn negative. And so these zeros are essentially the values that we see the change happening at. So my next step, we're doing this just like we did the rational ones in the last section. My next step is going to be to draw a number line and put those two zeros on the number line. Remember to put them in the correct order. So the negative 2 would come first because it's smaller, and then the 6 would be to the right of that. You want to check a number on either side of the negative 2 so that you can see whether the graph starts positive and changes to negative or whether the graph starts negative and changes to positive. So we're going to choose test values. So something to the left of negative 2, I'm going to use negative 3. Something between negative 2 and 6, I'm going to use 0. And something to the right of 6, I think I'll use 7. And again, remember that as far as the test values go, you can choose anything that you want. All right, to plug these values in, what I need to do is plug them in to the expression that has the 0 on the other side. Because what I need to know is when I plug a negative 3 in, am I getting something that's less than 0, in which case it's negative, or am I getting something that's greater than 0, in which case it's positive? So I'm going to begin with the negative 3, and I'm going to plug it in for the x's. and I'm going to work it out. So negative 3 squared is 9. Minus 4 minus 3 would be plus 12. And then we have a minus 12. And so the answer will be 9. And again, we're not that concerned that the answer is 9 so much as if the answer is positive or negative. So I'm going to put a plus right here indicating that any test value in that section would give a positive result. So the next thing I'm going to do is take that same expression and I'm going to plug a 0 in. So we'll have 0 minus 0 minus 12, which is going to equal a negative 12. So I'm going to put a negative in that section. And then finally, we'll check our third test point, and so we'll plug a 7 in for the x's. So we have 49 minus 28 minus 12, which is going to give me a positive 9. And so we'll put a plus in this section of the graph. All right, so once that's done, we're going to go to our problem and we're going to look at whether we want the positives or the negatives. Because the equation says less than or equal to 0, we know that negative numbers are less than or equal to 0. And so we're going to go to our graph and we're going to shade the parts that are negative, which is this middle section. And again, we'll look at whether we want open circles or solid circles on the edges. So remember, I'll write this up here again, if it's less than or equal to or greater than or equal to, you're using a solid dot. And if it's less than or greater than, you're using an open dot. And so because ours has the equal to, we'll be using a solid circle on both endpoints. And then finally, you want to write your interval notation. So writing the interval that we shaded, we begin the shading with -2. We'll use a bracket because it's included. And we end the shading at 6, and again, use a bracket because it's included. All right, so the steps here are essentially the same as they were for the rational inequalities that we just finished. You basically want to take your expression, make sure that it's set equal to 0. Find your zeros, use those to divide your number line into different sections. Choose a test point in each section and plug it in, noting whether that gives you a positive or a negative answer. And then identify the sections that answer the question asked. All right, so I'm going to go ahead and look at one more example with you. This one, we want to solve x squared plus 7x is greater than 0. And so again, we want everything to one side and 0 on the other. That part is done for us. And so the first step is taking our expression, which is quadratic, and finding the zeros for that expression. So we know that if we're looking for the zeros, we can factor an x out of these two terms. So I'm taking an x out of an x squared. That's going to leave me just an x. I'm going to take an x out of a 7x, which will leave me just a 7. And then we're going to take both of those factors and set them equal to 0 and solve. So the first one, x is equal to 0, that one is complete. We don't really need to do anything else with that. For the second one, I'm going to subtract the 7 from both sides. And so we'll have x is equal to -7. So now we draw a number line and we place those zeros on the number line in the correct order. So -7 comes first and then 0. Remember that these are potentially the points where it's going to change from a negative to a positive on your graph because it'll cross the x-axis at those points. So let's pick a test point. I want to pick something that's smaller than -7, so I might go with -8. Between -7 and 0, I'm going to choose -3. And greater than 0, I'm going to choose 2. Again, you pick whatever you want for your test values. Then I'm going to take my x squared plus 7x, and I'm going to plug these values in, noting whether we get positives or negatives as our answer. So first I'll plug in a -8, which is going to give me 64 plus a -56. And so that answer is going to be positive. And so I will put a positive here. We'll then plug in a -3 for the x's. So -3 squared is 9. 7 times -3 is -21. And so that's going to give us a negative answer for this section. And then finally, we'll plug in a 2, which is our test point for the third section. 2 squared is 4. 7 times 2 is 14. That's going to produce a positive answer. So now we need to determine whether it is the positive answers or the negative answers that meet the criteria given. So we want numbers that are greater than 0. Numbers that are greater than 0 are our positives. So we will shade the positive sections of the graph. Remember, color in your arrow, and then shade the sections that have the pluses. Because our problem is just a greater than and not a greater than or equal to, I'm going to see open circles on the endpoints, showing that those are not included. Then we'll write our interval notation. So our shading begins at -infinity, and we shade till -7, and that -7 will have a parenthesis. All right, and then our second section, we begin shading at 0 with an open parenthesis, and we shade until we get to +infinity. So again, on these problems, you want to be prepared to do a number line where you show the graph and also write your answer in interval notation.